Alright, so before we even get started on this, I'm just going to tell you right off the onset, I think this is one of the hardest problems that we've done in this course up to this point. So I would encourage you to go back through after you watch this video once and take these notes, to watch it through again and see if it makes sense to you. We're going to do some other types of problems like this in class on Monday, but we need to make sure we understand what's going on here. So it says a rectangle has one corner of on quadrant 1, or in quadrant 1 of the graph, y equals 16 minus x squared, another at the origin, a third at the positive y-axis, and a fourth point at the positive x-axis. Express area A of the rectangle as a function of x. I don't think we're even close to being able to do this yet. The first thing that we always should do is draw a picture of this. I want to take a second and think about this equation first. This function right here, 16 minus x squared. I think we have an idea of what that should look like, right? Negative x squared is a parabola flipped over, right? And so if we looked at this and we flipped these around a little bit and it was negative x squared plus 16, this is a parabola flipped over that has been shifted up 16 places. And I've done us a favor already and found a nice version of this graph and created it here. Let me erase what I had in there. So when I get rid of this, we can see here's my graph right here. And now let's try to make sense of what that said. So it says a rectangle has one corner in quadrant 1 on the graph of 16 minus x squared. That is this point right here. And when you take a look at that point, all we know is that point has an x value and then it's got a y value somewhere on there. I also want to point out that this is the equation y is equal to, or this is the graph of y is equal to 16 minus x squared. So to find this y value that we're talking about right here, we would just take this x and whatever it is, plug it in. It also says another point at the origin, so that's why we got this one down here. It says a third on the positive y-axis, there's that point right there, and then a fourth on the positive x-axis. So these are those points. It says express area as a function of x. So let's think about what type of graph we have. Area is equal to length times width. This looks like a square. It's some sort of rectangle. We're not sure if it's exactly a square. Actually, I know it's not because this actually goes up to this looks like around 7 and that's 3. This graph's kind of skewed a little bit in terms of our dimensions. But we have area is equal to length times width. Let's see if we can try to figure out what this length and width are. So let's take a look at the length right here. What is this distance? It sure looks like it's 3. We can't be exactly sure. We just know that it's some value of x. It's however far we went to the right here is how we constructed this, right? And now how far up did we go? It looks like it's somewhere between 6 and 8, but to make sure, all we know is it's this y value right here. It's however high we went up to get to this point. Now one thing to think about is we know is y is equal to 16 minus x squared. Let's keep that in the back of our pocket because we're going to be also, just like in the last problem, we're going to be doing some substitution here. So we have area is equal to, we know that our width is x, right? So we can substitute that x in there. And then our length is y, right? So that would get us our area is just to do y times x. But unfortunately here, I don't want 3 letters in this, so we're going to do some substitution. We know y is equal to 16 minus x squared. So we're going to substitute that in there. So our area is going to be equal to 16 minus x squared times x. And we can bring that x in here. So we're going to get area is equal to 16x squared minus x squared times x is x to the third. And now it says, what is the domain of A? We're going to rely on a graph for this, so I would encourage you to go ahead and put this into Desmos. That's what I'm going to do as well. Sorry, if that was loud, I just threw my pen. So let me get this over here. So it's 16x squared minus x cubed. And when I graph that, let me zoom in a little bit. we can see what is our domain. Well, 0 would be the smallest one, right? And then what is the largest x value? I can't have a negative area. Remember, y is going to be the area of this function. So I can't have a negative area, so that's the largest one. So it looks like our domain is from 0 to 16. It says graph A is equal to A of x. For what value of x is A the largest? Well, what we're looking for is we're looking for a maximum here, right? Do we see any relative maximums? I see there's one right here. And what does that look like? It says the x value is 10.667 and the y value is 606.815. So let's round these each 2 decimals. 10.67 would be the x value. And it looks like the y value, or the largest area, so that's the largest length, would be 10.67. If we wanted to find that's the width. If we wanted to find the length, we would plug in right here, and we could just plug in 10.67 and solve that, right? And now the y value would be this largest area, which is 606.82.